Word problems in 2.3. So a person standing close to the edge on top of a 28-foot building throws a ball vertically upward. The quadratic function, this one, models the ball's height about the ground, about the ground. H of t in feet, t seconds after it's thrown. What they're saying here, guys, there's a lot to be said about this. Because here's like the plus 28 is the fact that the height is already 20 feet off the ground because he's standing on top of a 28-foot building, whatever. Anyway, so the T stands for time, and the H of T is like the height at any given time. And then there's more about this stuff with falling objects. But whatever. Quick take would be something like this. Maximum height of the ball they're asking for. They're saying essentially, guys, remember, if I plug in different numbers for the amounts of time that this thing is thrown in the air, then I'll get different heights out of it. I plug in times, I get heights out. So if I plugged in like 1 second, then I'd go like 1 squared and then 108 times 1, and I'd do all the thing. And then what I would get out of it is a height, meaning like after 1 second, how high up is this thing? It started at 28 feet up, plus however much height we gain when we throw this thing at 108 feet per second, whatever. Anyway, so that's what it means. So in the basics of this thing, they're wondering what is the maximum height of the ball, meaning like at some point, this ball is going to start coming downstairs again, and we got to figure out how high does it get up before it does that. So maybe what we could do is figure out the amount of time that goes by before we hit the maximum value, and then we'll just plug it in to figure out what the time was or something. That seems to make sense to me. I don't know. Quick take could be something like this. Maybe we'll picture this thing is another vertex type issue, or it's a quadratic function, and we're looking at it's a negative 16t squared. So the height essentially of this thing, because it's a height function, is being mapped like as time goes by. Times are like 0 seconds, 1 second, 2 second, 3 second. As time goes by, this thing is starting up at 28 feet, already 28 feet up. It goes up, 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 and then down, 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 down. And after some number of seconds, it's going to hit the ground again. But after only a few seconds, it's going to be as high as it's going to go. And that's what we're going to figure out. But that's a vertex thing. That is a maximum value thing. And that's what they're asking for. And so here we go. If we were to do that, let's see if we can figure out the vertex. And we'll figure out the time involved of when it hit its maximum value, and then what they're asking for is how high was it? What was the height involved, or the y value, or the function output when it hit its maximum value. And so something like that, we would handle it like we do with all of our other quadratics. Let's see. If we did the whole x and y thing, but now it's time is the input, time is input instead of x, and then height is the output, or h of t is the output. Sorry for the mess. Anyway, so if I plug in 0 seconds is a good start point, and we know it started at 28 feet on top of the building. So if we plug in 0 here, 0 squared plus 108 times 0, this is 0 plus 28. Indeed, at 0 seconds, we're at 28 feet up. And then we'll find a new 0 like we do to find a vertex. And so let's see about this. These are ugly numbers, so let's see, we'll put the plus 28 like we do, and then let's see here. Something goes into both of those. It ain't very much, though. So maybe I'll pull out a negative. If we're looking at here, there's a negative in front of the 16, so I'll pull out a negative, and I think 4 is the best that I could do with both of those numbers. And so let's see how this goes. If I take out a 4 and a t, squeeze a t in there, 4 and a t, trust me, it's there. Then we have 4 times 4 is 16, so 4t left inside, minus, because we took out the negative, so that's a minus now, and then 27? Yeah. 4 times 27 should be 108. That's looking good. And that'll help me to find the new 0. It's not as obvious, though, what that new 0 is, so we're going to have to do it the old-fashioned way, 4t minus 27. If I want it to be 0, then we'll solve it out, and we'll do the little plus 27 thing and divide by 4, and by the time we're done, that's 27 fourths. And so the time involved in this vertex, or no, sorry, we're not at the vertex yet. 27 fourths, that's the other new 0, so 27 fourths is the new 0. That will also give me 28 out, and then we got to find ourselves a vertex. Vertex, of course, being, once again, half as far as that 27/4. And so remember, you can always do this by just dividing by 2 or timesing by a half. And so that's going to be 27/8 will be where our vertex lands. And so 27/8 is halfway to the 27/4. So if you want to do that on paper, that's 27/4 times a half. Gives you halfway as far, because we're doing that thing with the 2 matching dots and then the line goes in the middle. And then 27/8, if we do 27/8 and we shoot it into the function, we'll just see how ugly that gets. Feel free, if you can get away with it on these ones, go ahead and try the decimal version. Maybe we will, actually. It goes into 27 3 times with 3/4 left over, right? So 8 times 3 is 24. So yeah, so this should be like 3.75 if you want to divide it on a calculator. It should be that. That might be easier to work with, or else if you prefer fractions, just shoot it in there like that. But we're going to plug it into the function and we'll get ourselves a height out. And so then either one will be fine. I'm not going to do that part. I'll let you guys run those numbers. Anyway, and so that'll be some number, and that is the max height. Remember, don't give them this as the maximum height. They're asking for the maximum height. These things are times that we plug in. This is a number of seconds. So what we know is that after 3 3/4 seconds, 3.75 seconds, that thing has hit its highest height. Like, that's how much time has gone by, just before 4 seconds. And then how high was it? Well, we don't know until we plug that number in. So you take that number or that number, whatever, and plug it back into your function and see what maximum height it gives you. Tried that, and then also it asks how many seconds until it hits the ground. And so remember, hitting the ground is a height thing as well. It just means that it started at 28 feet high, it went up for a while, and then it came back down until the height was getting down further. At some point it hit 28 feet again, and it would go further down until it hit the ground. And that ground there is a height of 0, because now the height has gone all the way down till it's got no more height. And so that's what we'll say. Maybe we'll just go and we'll just say, well, okay, how many seconds until that height is 0? And so we'll just plug in a 0 for the height over here at that point. And you'd be like 0 equals -16 t squared plus 108t plus 28. And then we'll do our best to solve that thing out. My quick take on this, what I'm thinking is, we could probably start by taking out a common factor to make this easier. Maybe take out that -4 once again, but from the whole thing here, since we're trying to solve it for 0. And then we'll have a 4t squared minus like a 27t plus, what is that? No, minus 7. That'll be good. And then from there, you could even just divide the 4 out from both sides, because 0 divided by 4 will be 0 still. So we really won't need it. It doesn't have a letter on it, so we're cool. Or a variable value, whatever. And so then from here, it's a matter of, we'll do this whole factoring and make it equal 0 thing like we do. I'm going to give you just kind of a skip to the end on that. When I do this one, I'm getting something like t minus 7 times 4t plus 1. I got to figure out how I want to draw my t's. But that's not real obvious how that came about. And so if you don't remember how to factor things like this, guys, it might be worth just going online and getting a review. Maybe I'll put a resource in Canvas about it, about how to factor things that have the number next to the squared term. It's kind of a mess. You can do it by grouping. If you're looking for what to look up, you can do, say, factor trinomials by grouping, or by the AC method, or some people like the X method factoring, or there's a bunch of different ways. There's a box method of factoring some people like. However, any way you like it, there's a newer way that I never learned when I was growing up that's called, you might want to look into, it's called the snowflake method. It actually has another name too, but it's popularly known as the snowflake method of factoring. Not something that I've gotten real comfortable with doing, because I still don't know why it works the way it does. Although I was thinking about it the other day, and I think I kind of started to figure it out while I was driving, but whatever. Anyway, but it works super fast and good, so that's cool. Otherwise, maybe an AC method is normally equivalent to what I teach my classes, whatever, some kind of a factoring thing, and then you solve these things both out. I'm getting, in this case, t would be either 7 or -1/4, and -1/4 doesn't make sense as a time, so it must be after 7 seconds in this case.